At least I have the slide to show you. Okay, so now we move to the chapter 2, element of the high quality program. Okay, in this chapter, you learn about the display and using variable and constant perform arithmetic operation, the advantage of modularizing the program, hierarchy chart, and feature of the good programming design. Understanding the data type, what value can be held by the item, how the item is stored in the memory, and what operation can be performed on the item. So basically, you have many types of data. The first one is string here. The first one is string. String, you can see. If you say you have the, you can say you have the thing about it's an what is it? You can think about the name, right? You can have the name. That is a name, that is type string, right? So you can say you have the my name is Hieu Tran here. This is in the string. So what is string? The string is a combination of multiple characters. So each of them is a one character here, right? So this one in the string format. This one is string format. So if I have the character, I set it here. It's T. This is one character. So this is a character. This one is string. The string is a combination of multiple characters, right? So you also have the type of integer. Integer, it is a whole number here. It can be negative or positive. So we have number 2, number 4, number -5. They are integer, right? Or you can have a floating number. Floating number is the number you have both of integer and you have a floating point. So you have the 4 side here. Right? You have that is a floating number. So we will talk about a little bit about. We talk about the multiple data type later on this class here, but right now you understand that you have many types of the data type. It can be string, it can be a character, it can be integer, or it can be floating point here. That is very some of the basic very basic data type here. And the item stored in the memory is not the same. So think about if you have integer, you can reserve for 16 bits in the memory here. But if you have the floating point, it can account for the 64 bit here. So they are not the same. So it depends on the data type. It can occupy a different memory in the memory here. Right? Okay. So what operation can be performed with the item also? For the integer floating point, you can add them together. You can multiply them together, right? But for the string and the character, you cannot do that. Right? So that's why you have to understand the nature of the data type here. So the own programming language support of this data type, you have numeric here. Numeric is a number. You can add them together. You can subtract it together. And have the string. String is not use anything with the math. You cannot multiply string together. You can take the division here. Right. Okay. Now you have two types of the constant here. The constant. So in the last class, we know that you have something about the variable. The variable is something you have the slot in the memory, and variable it is reusable. It's changeable, right? It's variable, it's changeable. So we have to say you have width here in the program. So the first time you can enter the number 10, and the second time you can enter the number 20. It's override, and you're able to reuse it here. But the constant here, the constant is something. It is constant. It never changes. It's never changed here. It is a literal numeric constant. It contains the number only, and the number here it is always stay the same, not change. It's a numeric constant. Or you can have string constant, and so it can be the alpha numeric value. It never changes. So when we talk about the constant, it never ever changes. Right? So you have two types. You have the variable, changeable, constant, always stay the same. Okay. So working with the variable at name, memory, in location. That's the last time I talked it. I mentioned it to you. Right? So whenever you work in the variable, remember that you always have a slot in the memory, and a slot here is the name of the variable name, right? So we have the width. That means it reserves one slot in the memory, and the name is the width. So every time people want to access it to the width, it look into the memory and pull out the data from the memory here. Okay. And the constant can vary. That is variable, right? It's vary. And declaration is a provide variable. You can have the data type, identifier, that is variable name, or optionally you can have the initial value. If you look into the router, you have something initialized, right? So think about this one. You can some of the program you have to declare variable first. So have declare. You have declare. Sorry. So you declare. So you have width as integer. So what is this? This is a keyword. This is a variable name, and this is a data type. That is the thing if you want to declare the variable. That is one of the example you want to declare the variable here. Okay. So for this one here, you working with variable. So the first thing you declare the two variables. So for this one, you have two variables, my number and my answer, and they are in the number format here. They are number format, right? So after that one, you get input from user, input my number. So after this one, you have one slot in the memory, and the name is my number here. So after this one, okay, this one is processing. So this one processing, you have the my answer now. So remember, whenever you declare, you only have one slot with the name here. You only have one slot with the name here, right? So we see you have this one, you have my answer. So okay. So at the beginning, you declared, you don't have anything here. Now after the input, my number, you enter the number 10. It's slot in the number in the memory with the value 10 here. Now after this processing, you have assigned the my answer equal to my number times 2. So what is it? After this step here, it point out to the memory slot my number. It take it out number 10 and times 2. You got the 20 on this one. Right? So this one input processing, you only have the 20 here in the memory. The last step, you have to print it out. Right? So that's why you have the output here. So basically, for every program, it's very simple. You have the input, you have processing, and the output here. It's very three basic steps on that one. Okay, you have numeric variable. It holds digit and can perform mathematical operation on it. The string variable can hold text. Right? So remember this one digit, this one text here. It can be the letter or character of the alphabet. Special character such as punctuation mark. What else? Okay, an identifier is a variable name. That's all. It's a variable name. And program can choose a reasonable and descriptive name for variable. One thing about this one. One thing about when working with program here. Even though for the program of the figure out the area of the rectangle, you can set the input x. Input x, you can think x here is the width, and you have the input y. You can think here y is the length, and after that you have area equal to x times y. Nothing wrong with this one, but try to avoid it. So when you use the variable, try to make it meaningful. So and think about instead of x, you put it with here. So the end user has to figure out what is the meaning behind the variable name here. So we see it makes more sense than x here, and the length it makes more sense than y. So that's why when working the variable, try to working with reasonable name here. Try to make it more meaningful. Try to make it more sense here. So for the variable here, most of the language allows the letter and the digit. You can combine them together. You can combine them. Some of the language allows the hyphen, and you have the reserved keyword here. So in the variable name, you cannot use the keyword. Okay, that is the same thing. You also have to pay attention to that. It is case sensitive. It's a case sensitive. So if you have width and width, they are not the same. They are not the same because they are case sensitive, right? So in the case that you input the width here, but in the operation you have area, if equal to width times length here, you got the syntax error because the program it doesn't understand what the width here. Because the width here in the lower case and this here in the upper case, they are not the same. Right? So that's why you have to pay attention to variable name. They are the case sensitive and must be one word only. You cannot have the space in the variable name, and it must start with the letter and should have some appropriate meaning. That is also you have to pay attention on to that. Okay, so for this one, again, you have declaration, you have the input, processing, and the output. I don't want to go into that as well. Okay, and you have some of the convention. You have the sum of the convention when working with the variable name here. Convention here, right? You can use a camel casing, variable name, the hum in the middle. So see, our wedge here. Right? You have hum on this one, or you have the Pascal casing. You have the first letter in each word in the uppercase. Our wedge here. Right? Or I can use the Hungarian notation. It's a form of camel using the data type, the part of the name. So we have nam, hourly wedge here. So it's up to you. It doesn't matter that you have to follow this one, but normally it follows the convention. It makes more sense for the programmer here. Okay, so here is some of another convention. You can look on as a reference, but you don't always have to follow it. It's up to you here. Now, remember, you have input, right? You have input. Now you do everything is processing. Processing, you can call it the assignment statement. Now you remember that you have the two input. It's the width and you have length here. Right? They are the two input. Now, if you want to figure out the area, you have to working with the assignment. So you have to set, for this one, you have to set area equal to the length width here. This is they call it assignment. So why assignment? Assignment, that means you assign the length times width, you assign the value width to the area here. Right? So think about you have the width number 10 and the length number 20. After this one, you assign the area here. You assign area, and now area take the value of 200 here. That's all. And remember, when working the assign operator, you have to use the equal sign. You have to use the equal sign here. And it requires the two operands, one on each side, always operate from the right to the left. Remember that you have to figure out what's the length of the width. So after you have 200, you assign it to the memory name area here. Right? You're always working from the right to the left here. Okay. Okay. So sometimes you have to initialize the variable. The thing about this one, you have initialize the variable that it declares the starting value. So at the beginning, you can initialize the authority here, the 14.525, or you have your name, it's generated here. But of course, we always able to change it because there's a variable. Right? Some of the programming they require you have to declare the variable and you have to initialize the variable first before you can use it. But some of the programs you don't have to declare and initialize the variable. What is it? Okay, now we move to the name constant. Remember one thing about this one. The constant, it never changes. It never changes. Right? So the name constant is similar to variable. It can be assigned value only once. Right? And assign the useful name to values that will never be changed during the program execution. So sometimes they call it the magic number. They call it the magic number. The magic number, what is it? You see, you figure out the tax amount equals the price times 0.06 here. So if you are the programmer, if you are not the one who coding this one, you have to take time to figure out what is the 0.0.06. Right? If you look on the coding here, you have to figure out what is the 0.06. So we have to go back. You have to find out, oh, this one actually is a text percentage here, right? So instead of that, you're using the price times sale tag amount here. And at the beginning, you assign the sale. At the beginning of the program, you have the sale tax amount. You assign the 0.06 here. So every time, think about if you have a very, very complicated program and you have to use the sale tag amount for multiple times, not only one. Right? So every time you use using the sale tag amount here, actually you time it to 0.06. But instead of using the magic number, this one is the magic number. You have to take time to figure out what is it. You can use on this one here to make more sense if you are the programmer. Right? So try to avoid using the magic number. Instead of that, try to use the name constant. Okay, so now we're working with the arithmetic operation. So when you have the number, you can add them together. You can minus it together, time together, this one time together, or you can do working with the division also. And of course, you have the rule of the priority. Right? Not always the same, right? They are not always have the same order of the operation here. So we remember that if you have everything inside the parentheses here, you have to do it first, right? And if you have something with the multiplication and division, you have to do it next. And the last one, if everything with the addition and the subtraction, you have to do it the last. Right? So you have to work in the priority here. Okay. Okay, so you see, you have the height here. So basically, if you have working with practices, you have to working first, and after that, working the division and multiplication. If they are on the same order, you have to working everything from the left to the right. Right? Remember that, left to the right. Okay. When you divide the two integer, remainder operator here. So when you have remainder operator, you have the 24. Sorry. 34, you divide by 10, you have the 4 is the remainder. That is they call it the modular. Sometimes they call it the modular. Okay, now that is something you also understand when working in the program. That is the modularization, the program of the modularization here, modularization. Okay. So for this one, I cannot work with Raptor on this one. I could try on this one, but not able to work. Can you try to work with Raptor on this one? Okay, so I think seems that we are not able to do it. But again, I can show you some definition. What's the modularization here? So basically for the program, if you can think about, you have very complicated program, right? Okay, very complicated program here. So instead of doing it by the one team, you can break it down into multiple module, sub-module here, right? So you can break it down one sub-module, the second one, the third one, and even for the sub-module here, you can break it down furthermore. You can break it down into multiple sub-module here. So when you're breaking down from program into multiple into the module, you have the sum of the benefit here. They call it the functional decomposition. So what is the benefit of this one? What is it? Okay, so here's the benefit. Okay, and the thing that I don't know if you have the operation to install the software in our computer.
What do you need to install?
Router.
Okay.
Router.
Well, wait a minute, that indicates it's there.
It requires to install the network.
All right, do that. I'll how you do it. It's been a while, but oh, crap. I gotta go get my cell phone because it has my password.
Okay, okay.
I'll be back in just a second. Steph, is my cell phone in there?
Okay, so I think it's the time you can working with
We can't hear anything.
You cannot hear me? Sorry, you cannot hear.
I'll be teaching you everything you need to know about UML use case diagrams. We'll start with a high-level overview, then we'll talk about systems, actors, use cases, and relationships. And finally, we'll build an entire use case diagram together and go over examples to explain these concepts in depth. Have you ever had an idea that makes perfect sense in your head, but when you try to explain it to someone else, they're completely lost? Maybe your idea is for a new app, and every time you talk about it, people don't really understand how they'd interact with the app or what it would do. This type of scenario is where a use case diagram is very helpful. Here's a simple description of a use case diagram. First, it shows a system or application. Then it shows the people, organizations, or other systems that interact with it. And finally, it shows a basic flow of what the system or application does. It's a very high-level diagram and typically won't show a lot of detail, but it's a great way to communicate complex ideas in a fairly basic way. Before we really get into the tutorial, let's talk about how you're going to make a use case diagram. You can draw them out with pen and paper, but a diagramming application is going to be much easier. Today I'll be using Lucidchart, and you can too, for free actually. Just click the link to access Lucidchart's website. enter your email address, and you'll have a free Lucidchart account in just a few seconds.
For this class, you don't have, you have the tutorial, you're working with Draw.io here. So when you click on Draw.io, you can working with save it somewhere. So if you want to create a new diagram, you can click on this. You can click on this and working with a blank diagram here. Save to somewhere. Okay, so when you look on the left, you have something of a general here. You have something of advanced. You have something working flowchart. If you want to work in flowchart, and you have unified here, modeling language here. That's the one you're working with this one here, right? So that is very helpful in the planning. In the designing step. You can draw all of the how the thing interact together. So if you think about, you have the bank bank transaction application here, right? So we can see how they interact together. You have the end user and you have the bank, and they interact together. You have to log in. You have the option to log in to verify username, password, and you have option to deposit money. You have option to transfer, or you have the option to withdraw the money here. That is the case of the use case. Yeah, use case diagram here. Remember, you don't have to follow this one. You're just working with for this one, working with what was it?
Sorry, I'm just making sure my phone isn't in here. I've now lost my phone.
Oh, sorry for that.
No problem, we'll figure it out.
Seconds. It's easy to use, and you can follow along with me as we build a use case diagram. Okay, so we're going to break down use case diagrams into 4 different elements: systems, actors, use cases, and relationships. Let's start with systems. A system is whatever you're developing. It could be a website, a software component, a business process, an app, or any number of other things. You represent a system with a rectangle, and you put the name of the system at the top. We're going to build a use case diagram for a very simple banking application. We'll call our system Banking App. This rectangle helps define the scope of this system. Anything within this rectangle happens within the banking app. Anything outside of this rectangle doesn't happen in the banking app. The next element is an actor, which is depicted by this stick figure. An actor is going to be someone or something that uses our system to achieve a goal. That could be a person, an organization, another system, or an external device. So who or what is going to be using our banking app? The most obvious actor is a customer. We are going to have customers that download and use our banking app. Another actor that we'll want in our diagram is the bank. The bank is going to provide information that feeds into our banking app, like transactions and account balances. Here are a couple things to keep in mind when dealing with actors. First, it's important to note that these actors are external objects. They always need to be placed outside of our system. Second, actors need to be thought of as types or categories. For our banking app, an actor isn't going to be a specific individual or a specific organization. We wouldn't label our actors as John and Chase Bank. We want to keep things categorical. So right now we're saying that both customers and banks are going to use our app. And this brings up the topic of primary and secondary actors. A primary actor initiates the use of the system, while a secondary actor is more reactionary. So in our example, which actor is primary and which actor is secondary? The primary actor is customer. The customer is going to initiate the use of our system. They're going to pull out their phone, open up our banking app, and do something with it. Bank, on the other hand, is a secondary actor. The bank is only going to act once the customer does something. If the customer goes on the app to see how much money is in their account, only then does the bank engage with our system to provide the balance. Primary actors should be to the left of the system, and secondary actors should be to the right. This just visually reinforces the fact that customer engages with the banking app and then the bank reacts. The next element is a use case, and this is where you really start to describe what our system does. A use case is depicted with this oval shape, and it represents an action that accomplishes some sort of task within the system. They're going to be placed within the rectangle because they're actions that occur within the banking app. So what is our banking app going to do? We're going to keep things very simple. Our banking app is going to allow a customer to log in, check their account balance, transfer funds between accounts, and make payments towards bills. So if this is what our banking app does, we're going to have use cases that describe each of those actions. We'll have a use case called login, another called check balance, another called transfer funds, and finally make payment. You can see that each of these use cases starts with a verb and reinforces an action that takes place. We also want them to be sufficiently descriptive. If this use case just said transfer, that'd be too vague. Finally, it's good practice to put your use cases in a logical order when possible. That's why we put login at the top. That's the first thing that will happen when a customer uses our banking app. The final element in use case diagrams are relationships. An actor, by definition, is using our system to achieve a goal. So each actor has to interact with at least one of the use cases within our system. In our example, a customer is going to log into our banking app. So we draw a solid line between the actor and the use case to show this relationship. This type of relationship is called an association, and it just signifies a basic communication or interaction. A customer is going to interact with the rest of these use cases as well. They're going to check balance, transfer funds, and make payment, so we'll draw solid lines out to each of those as well. Secondary actors will also have relationships. Remember, each actor has to interact with at least one use case. So which use cases will the bank interact with? When a customer wants to check their balance on the app, the bank is going to provide the correct amount. Let's draw a line between bank and check balance. Similarly, when a customer wants to transfer funds or make a payment, the bank is going to follow through with those transactions. We don't need to draw a line to log in because that process happens within the banking app. There's no need for the bank to actually get involved with the login process. There are three other types of relationships in addition to association. There's include, extend, and generalization. Let's build out this diagram with additional use cases in order to explain these types of relationships. When a customer types in their login information, our banking app is going to verify the password before completing the login process. But if the password is incorrect, the banking app is going to display an error message. So let's create two new use cases for verify password and display login error. When a customer wants to transfer funds or make a payment, our banking app is going to make sure there's enough money to complete those transactions. So we'll also create another use case called verify sufficient funds. And finally, when a customer wants to make a payment, our banking app is going to give them the option of paying from either their checking account or their savings account. So we'll create two more use cases called pay from checking and pay from savings. Let's circle back to this verify password use case and talk about relationships again. How does verify password relate to the rest of the diagram? Neither of our actors are directly initiating this action. It's just immediately going to happen within our banking app every time there's an attempt to log in. This is an include relationship. An include relationship shows dependency between a base use case and an included use case. Every time the base use case is executed, the included use case is executed as well. Another way to think of it is that the base use case requires an included use case in order to be complete. When you have an include relationship, you draw a dashed line with an arrow that points towards the included use case. So in our example, login is the base use case, and verify password is the included use case. Every time a customer logs in, our banking app will automatically verify password. This login use case won't be complete unless verify password is complete. So we draw a dashed line with the arrow pointing towards the included use case, and we write include in double chevrons. The next type of relationship is the extend relationship. An extend relationship has a base use case and an extend use case. When the base use case is executed, the extend use case will happen sometimes, but not every time. The extend use case will only happen if certain criteria are met. Another way to think of it is that you have the option to extend the behavior of the base use case. When you have an extend relationship, you draw a dashed line with an arrow that points towards the base use case. In our example, login is a base use case, and display login error is an extended use case. Our banking app won't display a login error message every time a customer logs in. This will only happen once in a while when a customer accidentally enters an incorrect password. Since this is an extend relationship, we draw a dashed line with an arrow that points to the base use case and write extend between double chevrons. Hopefully, this thoroughly explains the difference between include and extend relationships. But just in case, here's a very basic example to help differentiate between the two. If you sneeze, you will close your eyes. That's an included relationship because it's going to happen every time. Additionally, if you sneeze, you might say excuse me. That's an extended relationship because it supplements the sneeze, but isn't completely necessary in the sneezing process. Just remember that include happens every time, extend happens just sometimes, and don't forget that the arrows point in opposite directions. One quick thing to note is that multiple base use cases can point to the same included or extended use case. For example, both transfer funds and make payment are going to point to verify sufficient funds as an included use case. We want our banking app to make this check every time either of these base use cases occur. You don't need to duplicate the verify sufficient funds use case. The simpler your diagram, the better. The last type of relationship we'll discuss is generalization, also known as inheritance. When you make a payment from our banking app, you can do so from either your checking account or your savings account. In this scenario, make a payment is a general use case, and pay from savings and pay from checking are specialized use cases. You could also use the terms parent and children. Each child shares the common behaviors of the parent, but each child adds something more on its own. To show that this is a generalization, we draw this type of arrow from the children up to the parent. You can have generalizations on use cases like we have here. You can also have generalizations with actors. In certain scenarios, you might want to distinguish between a new customer and a returning customer. You can make them both children to a general customer actor, which would allow you to have certain behaviors or qualities unique to each of these children. One last shape that we'll quickly talk about is a use case with extension points. You can see an example here. The name of the use case is above the line, and then there are extension points below the line. Extension points are just a detailed version of extend relationships. This use case shows that a customer can set up their profile in our banking app. And then these extension points show us that when a customer is setting up their profile, they'll have the option to navigate to a couple different screens. If a customer is confused, they can go to Profile Help. And if they want details regarding their private information, they can go to Privacy Info. Those extension points branch off to extended use cases. Go to Profile Help and show Privacy Info. We can even add a note to show what sort of conditions would lead to these extension points. Now we have a complete use case diagram with various elements that help explain what our banking app does. This is a very basic example, but remember that even complex systems should be restricted to a simplistic visualization of functionality, behavior, and relationships. If you'd like to take a closer look at
Okay, so that is video show you how to work in the user diagram, show you how to interact them together. Right? So if you look on this one, basically you only have the template. So the first step is download this one. Now download the template here. Where show the folder, so download here, right? So when you go to the draw diagram, you just click the file, you open from device. You have the device, and I save it in the download. This one. So basically for this one, you already have the actor here. You already have the actor. You have the actor for this one. It's actor for this one, and you have the score registration system. For this one, you have to create the user diagram process here. Okay, now you have to describe the registration process to a group for the first time student at the architect. Actually, I'm really not really sure about the process, how to work in the registration here. So if you open the draw IO, you already have the actor here, right? You have the two actors. Remember, when you put the name of the actor, you try to make it general. It's not too specific. It's not your name, right? So this one is to put the student, and what's this one? I think it's registration office, right? What is the first time working with the registration? How we working? If you are the first time working your registration process, you are student, how you interact with registration office, or right? I'm not really sure, right? So here, you can change the name. You can change the name of this one. Put its name here, student, and this one, you can change it to the registration. On. Okay. So again, if you remember when working with the Euclid diagram, you have something you have to remember about the Euclid diagram here. What is it? Okay. In the Euclid diagram, you have the system, you have the actor, you have the use case, and you have relationship. That's something you have to remember, right? The system, you have the rectangle here. Every application is inside system. Remember one thing, actor is someone outside the system and who interact inside with the inside system here. And the use case is every action here, every action you have, and you can have a relationship, how you connect together, how to interact together. So when you come back to the diagram here, you think the first time also, right, is you have to do with the login. Right? So when you go to the UML here, you have the user code here. Right? And if you click on this one, you can put it in the login here. Okay. So every time you log in, you have the interaction, you have the action from the student, you go to the login, you go to the general here, and you work in the solid line. This one is a solid one. Okay. This one is solid line. So you can drag and drop it. Okay, that is login. So remember that is the first relationship. You have in the use case diagram. So you break it down in the primary actor and the secondary actor. The primary actor is the one who initiates the use of the system, and the secondary actor is the one who do the reactionary here. And for the use case, it represents an action that accomplishes some sort of task within the system. Right? So in the relation, you have some type of relation. You have include, you have extend, and you have generalization. So for the include you break it down. You have the base use case and include use case. So remember, for the include here, every time you do the base use case, every time you do the base use case, you have to do with the include use case. So to make it easy, you see on the video, they have the very simple example, right? So every time you sneeze, you have to close the eye. That is the case of the include here. So every time the base use case work, you have to working with inclusive case. That is the include here. Right? So remember, in the case of include, you draw the line. It is a breaking line here, and you have the arrow on this one. So you can think about this one. Every time you log in, you have to verify the password here, right? So you can have another one. You have to verify the password. Okay. And remember, whenever you log in, you also have to do everything. It's a verify the password. So this one is include, right? This one is include relationship here. So in the case include relationship, you can use the line here. You put the line on this one and put the line this one. And you can change the line here. You can change this one. You have to change to the dash line here. And of course, you can change. You change the thick of the line, so we can put it more bold here. The same as this one. You change it to number 3 here. Okay. And remember one thing. In the some case, when you log in and verify password, sometimes the password is not correct. Sometimes not correct. So in that case, you have to working with the key extend here. So that is also the very simple example. Remember that every time if you sneeze, someone say excuse me, but someone's not, right? So that is when working the base UK, sometimes you have to work with the extend UK. And remember when work with the extend UK, you have the dash line, but the arrow it come back in the reverse way. It come back to the base UK here. All right. So for this one, you can put it here. Put it include here. But this one, in the case of error notification, this one is extended. So in the case of extended, it is on the reverse way. On the reverse way. So we have this one. One. And you can put it here. Is that okay? So, and of course, so after the login, what action you have to do with the registration? What action? I'm not really sure about that. I'm not really sure about the process here. You have to. You did it. What do you say? After the login to the IP tag, you have to.
Oh,
Hello. Yes. What do you think?
I was thinking that maybe your personal account after you log in.
Password. Anyway, it's up to you. You can work by yourself. So if it's a UK, you can use this one, right? And you drag and drop it, put it here. So what? No, not this one. Where's the URL? This one. This here. Yeah, is okay here. So it's up to you. You can write out here. What is it? I'm not really sure about the process, but it's totally up to you. That's something about the user case here. You have to understand something about the system. You have to understand about the actor. You have to understand about the relation here. And in the relation, you have the included, you have extend, and you have generalization. That's something you have to remember when we teach you. Submit button here, right? You don't see anything with the submit here, right? So in the case, if you don't see the submit here, I think you click on this one. Yeah, you run the check. You run the check. Right now you don't do anything, right? But if you in the homework here, after you do everything, you follow the step, you do everything. You run the check, and after that, you have to click the submit here. You can check if you have 100%. You just click the submit here in order to submit it. So remember, if you want to submit, click on this one. This one, you click on this one, and you can run the check. After that, you click the submit. That's all. That's the way you submit the Python in the Cengage.